Okay, let's start with number 10 on this video, and I'm going to split the screen here so we can see both. It says, what is the equation of the line through 2, 3, and 0, -1? Well, we can see that we need to find the slope, because if you look at your answer choices, the answer choices show that the slope is either going to be 2 or -2. So that's where we would go over here and write these points down, 2, 3, and 0, -1, and put this in slope formula. -1 minus 3 over 0 minus 2 is a -4 over a -2, which is a +2. So your slope is a +2. So we can eliminate B and D. It's either going to be A or C. I know you can see what the answer is, but if you couldn't. And then, so that brings us to looking at our y-intercept. It's either a -1, which is a -1, or it's +1, which is a +1. So this point right here is your y-intercept because it starts with 0. This number right here is on the y-axis, and your y-intercept is where the line goes through the y-axis. So this is your y-intercept because this point is on the y-axis, and that's why that is your answer. 10b, so it looks like from looking at the answers, the slope is either 3 or -3. So let's find out what this one is. I'm going to plug those 2 points into slope formula. 5 minus a -1 over 0 minus 2 is going to give us 6 over -2, which is -3. So at that point, we could eliminate B and D and look at the y-intercept now. Is the y-intercept a +5 or is it a -5? Here it is. It's a +5. That's why A is your answer. Okay, question 11. In which part of the graph is the height of the water increasing? In other words, which part of the graph is going up, which is part 3. Okay. Which part of the graph is the height of the water increasing? Part 1, where it's going up, where it's positive, increasing. If it said constant, that means it would be flat, like a horizontal line. Okay. 12, which part of the graph shows a non-linear? Non-linear means it's not linear. It's not straight. Again, I'll make a note over here. If a relationship is linear, it is straight, like a line is straight. If it's non-linear, then it has a curve to it. It's not straight. It's not a line. It's not straight. Okay, so which part is curvy? Non-linear, part 4. Next one, which is non-linear, part 2. Question 13. Which graph could represent this scenario? Vernon adds some flour to a partially filled bin by pouring it in at a constant rate, so it's going up constantly until the flour reaches the brim, and then he has to stop because it's full. So it's pouring the flour in. When it gets full, it stays constant because he can't put any more in. That one is not right because it's constant at first. He starts out pouring it in. Okay. And it's partially filled. That's why it starts right here and not at 0. Like this one. It doesn't say it's empty. It is partially full. 13. Which graph could represent this scenario? Ahmed fills an empty container with water at a constant rate. So this container is empty. It starts at 0. He pours it in at a constant rate, and we'll see what happens. He turns off the water when the container springs a leak, and then the water level decreases. That's why it's going down right there, until he can seal the hole. After he fixes the leak, the water level stays constant. So that's why it's that graph. Question 14. See how many more are there because my time's about to run out. I think I can do this. Which scenario could be represented by this graph? Jane lights a candle. The x-axis is the time, y-axis is the candle. As the time runs down, as it's burning, the height of the candle goes down. The last one is this one. Randy turns off the oven. After the oven returns to room temperature, he waits 10 minutes, then turns the oven back on. So he turns it off. It decreases.